Stanford University.
Okay, well, welcome then to Stanford CS103P, Developing Applications for iOS, Winter 2017. This is lecture number 5. Is that lecture number 5? Yeah, lecture number 5. And today we are going to start off with a little demo where I'm going to take the application that we worked on last time and add a model to it, because we had only worked on the view part of that, building that nice, cool face view. Now we're going to add a model to that MVC. Then we're going to come back to the slides, and I'm going to do some slides on gestures. Obviously, you want to be able to have input to your app. You need to know how to do multi-touch gestures. We'll talk all about that. And then I will go back to our face view application, and we will add some gestures, pinching, panning, tapping. And finally, I will go back to the slides again and start talking about multiple MVCs, how to build bigger applications that are made out of combining MVCs. So that's what's on tap for today. So let's jump right back into this face view, Faceit, actually it was called, demo. If you remember where we left off, we had this nice view. It was really cool because in Interface Builder, we could do things like open the eyes, we could make it really big, we could make it really small, okay, or anywhere in between, and we could change the color, here to green, something like that. Okay, so that's cool, and this is a nice reusable thing. It's got a little public API to it, right? These inspectable things are all public, so we can do things like set the mouth curvature, we can open and close the eyes, we can change those things like scale. So that's nice. It's this nice reusable face, and what we're going to do is make our MVC have a model. Now that model is not going to match up exactly to what our face view can do, because that's the way models work. Models in the world are often databases or something. Their schema doesn't quite match what view you have around, so the job of the controller is to interpret that model for the view as best it can, okay, and interpret input from the view also to affect the model. So let's go back to our controller. You can see that we have no model. We also have no outlets to our view here. So let's add both of those things. I'm going to start by adding an outlet to our face view. So remember how we do that. We get our storyboard on screen. I'm going to get them both on screen at the same time. And then I'm going to control drag. And I'm control dragging from my face view to create an outlet to it in exactly the same way I would control drag to a label or button or anything else. There's nothing special about the face view. So I'm just going to hold down control and drag in here. And I'm going to create an outlet. I'll call this outlet my face view. Okay, it's a perfectly good name for it. All right, hit connect, and there we go. We get this code that you're quite used to here, which is this IB outlet weak var. Okay, so now we have a connection to our view. And remember, in an MVC picture, the controller can have green arrows to its view, that's this, and it can have green arrows to its model. So let's create a connection to the model. So what is going to be our model of our MVC? I'm actually going to drag that in right here. It's called facial expression right there. When you drag things in, I strongly recommend you have this destination copy items if needed. Otherwise, when you drag in a class or struct or something, you'll be pointing to it. So if you change it in wherever you got it from, it'll be changing it in your project. So it's usually you want to copy. Maybe that might be what you want in certain circumstances, but usually you want to copy it in. So let's take a look at this thing that I brought in. It's a struct, and it's going to be the model of our face view, and it's a really simple facial expression. Okay, that's what this represents, this struct. And it has positions of the eyes, open eyes, closed eyes, squinting eyes. Unfortunately, we can't represent that in our view, but it's in the model. We'll have to figure out the best we can do. It's also got a mouth, and the mouth can frown or smirk or can grin or smile. Notice there's nothing in this model about mouth curvature. Okay, it doesn't know anything about mouth curvature. It just knows about grins and frowns, things like that. That's what the model is. It's also kind of cool. It knows how to, an expression knows how to give you a happier version of itself or a sadder version of itself. Okay, that's what these bars do. They just return a happier or sadder. But primarily this struct is just an expression that keeps track of the state of the eyes and the mouth. Okay, everyone got that? So I'm going to, in my controller, create a green arrow to it or a var for it. I'm going to call it expression because it's a facial expression, and it's of type facial expression. And actually, I might as well give myself a starting facial expression. Let's have our starting facial expression have eyes which are, let's say, open, and a mouth which is a grin. That sounds like a happy place to start, okay? So that's great. Now, remember that the primary job of a controller is to interpret the model for the view and vice versa. So I'm going to add a private function here, which you'll often have a method or a number of methods in your controller like this. This one I'm going to call update UI. Okay, and the job of this method is just to make the model match the UI. That's its job. Okay, that's what this method is going to do. So what do we have to do to make our model, this facial expression, match our UI? Well, we have to deal with the eyes and we have to deal with the mouth. Okay, so let's deal with the eyes first. That's pretty easy. So I'm just going to switch on my expression's eyes. And in the case that the eyes are open in the model, then it's easy. I can just take my face view and set its eyes open to true. Okay, that's obvious how I do that. And this face, you remember, is this outlet that I just created there. And so that's obvious. How about the case where the eyes are closed in the model? Well, that's the face view's eyes open are going to be false. And finally, there's this case in the model where we're squinting. And here, I don't really have a way to represent that, so I'm just going to say that in that case, our eyes are going to be closed, because squinting is more like having your eyes closed than having them open. But, you know, we don't always have exactly the view we want to represent our model, so we're doing the best we can here. Okay? So that is the eyes. Pretty straightforward. Now the mouth, I could do the same thing for the mouth here. Case expression.mouth. If it's a grin, set the mouth curvature to this. If it's normal, set the mouth curvature to that. But that code is kind of messy. So what if I created, make some space here so it's up higher. What if I created a little private var here? Actually, we'll even make it a let. And I'm going to call it mouth curvatures. And it's going to be a dictionary. And in the dictionary, the values are going to be facial expression.mouth positions. Okay, like maybe a grin. And the value is going to be a mouth curvature. So what's a good thing for a grin? I think I decided 0.5. Okay, so this is just going to be a dictionary with mouth position in the model, colon, mouth curvature for the view. See, so I'm just creating this little mapping data structure. So let's do this for all. Let's map this for all of our facial expressions right here. Notice, by the way, that Swift was able to infer the type of this dictionary, right? Because it only has one item in it, and the types of those two things are obvious from what they are. So now that it knows that, by the way, we can be a little more succinct and just say, like, frown is -1.0, and smile is 1.0, and obviously neutral would be 0.0. Did I get them all? Smirk, how about smirk? Nope, that smirk, we'll say, is -0.5. Okay, so I've just put those mouth curvatures in this nice little table. And so now in my update UI, I'm just going to set my face view's mouth curvature equal to looking up in the mouth curvatures the model's mouth. Got that? Okay, I just kind of want to do it this way to kind of show you that you don't always have to forcefully case every single thing when you have an enum. Sometimes you can use things like this. Now, I have an error there. Anybody know why I have an error? Can anyone guess? What? Optional, yeah. All right, people are getting the optional thing. Good. Okay, mouth curvature, what type is that? That is a double. And mouth curvature sub expression.mouth, what type is that? It's an optional double. And that's because this expression might not be in that dictionary. So I'm going to use that defaulting thing we learned and say, if I can't find the expression mouth, we're going to have neutral mouth, okay, not smiling or frowning as our curvature. Okay? Make sense? Now, we have this great update UI. When should we call this thing? Okay? Well, we certainly need to call this thing anytime our model changes. if our model changes to have a different expression, we got to update our UI. So how are we going to do that? We're going to use this cool feature that I talked about last time called property observers, this did set thing. Okay, so did set allows you on any of your vars, if it changes, you can execute some code. So anytime someone sets this expression, I'm just going to update my UI. Make sense? Now, there's one other place that I want to update my UI, though it's a little less obvious, and that is with this property observer. Okay, now what am I doing here? This property is the outlet, that thing I control drag to my face view. And when we first start up, it's not set. iOS takes a few microseconds to actually connect this up. That's why this is an optional, remember? Okay, so in that short amount of time, what if the model gets set? Okay, then update UI is not going to work because the face view hasn't been connected yet. So that's no good. Okay, also we initialize our facial expression to be this. When you initialize something, did set does not get called. Did set is only called if someone externally sets the expression. The initial thing does not cause it to be set. Okay, so when is this did set going to happen? It's going to happen only once when iOS hooks up this outlet to that face view. Then this did set is going to get called. That's the only time it's ever going to get called. But at that time, we're going to update our UI. Now, there's one other minor thing here. What if this gets called before this happens? Okay, this is going to crash our program. Because until this gets hooked up by iOS, this is nil. Okay? The only reason we don't have to say exclamation point here, remember, is because we have this implicitly unwrapped optional here, but it is an optional. So how can we deal with that? We don't want update UI to crash our program if the expression should happen to be set before that thing gets wired up. Now, that thing gets wired up pretty soon, so probably not likely to happen, but it could. So we're going to do that by using this chaining, this optional chaining. Remember the optional chaining where you can put a question mark there, and if the thing that you put the question mark on evaluates to nil, the rest of that line of code is just ignored. So perfect, okay? Face view question mark dot eyes open. If face view is not set, we just ignore that. We're not going to set the eyes open to anything. That line is just going to be aborted immediately. Okay? So this is something you often want to do in your update UI things is protect against your outlets not being set. Okay? And it's all going to be fine because if this got set and this has not been, and then this happens and none of these lines of code execute, no problem, because when this does get hooked up, this is going to get called again. And this time it'll be able to do it. Okay? All right. So that's it. Let's run our little app here and see if we get an open eyes grin. In other words, let's see if our UI reflects what's in our model. And sure enough, open eyes and a little grin. Okay, let's try closed eyes, closed, and a little frown. Okay. Bingo. Okay. So now we have done what we need to do in our controller, which is we're interpreting our model for our view. And anytime we set the model from now on, it's going to update our view automatically. So the question is, what if I forgot to put this little question mark right here? Probably everything would be fine because you don't set your model before that outlet gets wired up by iOS, because it wires it up really soon. But if you did, then what would happen here is it would crash right here. And so that's how you would know, oops, you know, messed that up. And sometimes you'll forget to put that question mark there. It's fine. You do all your coding and you never call that model earlier. But then later you change your code in a way that does set the model before that thing, and boom, it crashes and you find it right away. That's why crashing is not always the worst thing in the world. Okay, crashing helps you find bugs like that. You just hope you don't ship it out and customers find that bug for you that way. Okay. So that's it. That's all I wanted to do is show you. Now we have a complete MVC. It's got a model, it's got a view, it's got a controller that is interpreting for each other. So we can go back to our slides and learn about gestures, and then we'll add some gestures to this thing. Okay, so how do we get those touches? Now, it is possible to get notified of raw touch events, like a touch, meaning a finger went down on the screen, it moved, it went up, okay? 2 fingers went down. You can find out all about that, but we never do, okay? Too complicated. Trying to figure out whether this down swipe up is a swipe versus just moving, it's too hard. So we're gonna let iOS do that for us, and we call that interacting with multi-touch via gestures, okay? So we're not even going to learn about the raw touch input in this course, just gestures. So gestures are recognized by this class called UI Gesture Recognizer. Actually, not by UI Gesture Recognizer itself. That's an abstract class. How many people know what an abstract class is? Raise your hand if you know what that is. Okay, so I'll take a second. So an abstract class is a class that its only purpose in life is to be the superclass of other classes. And you never actually create an abstract class, okay? You only create subclasses of it, instances of subclasses of it. So UI Gesture Recognizer is abstract. You would never create UI, you would never call an initializer on UI Gesture Recognizer. Instead, there's a bunch of subclasses, which I'm going to talk about, and you would call the initializer on them, okay? Now, there's 2 parts to using a gesture recognizer here. One is you have to ask a UI view, please start recognizing this gesture, like a swipe or a pan or whatever. And then number 2 is when the recognizer does recognize it, it wants to call you back with a handler, what we call a handler, a gesture handler. So there's the recognizer that you add to a view, and then there's the handler. Anybody can be the handler, as you'll see. Almost always it's either the view itself or a controller, but anybody could be it. Okay? Now, the adding of the gesture recognizer is done with a method called add gesture recognizer in UI view, and that method is usually called by controllers. Okay, why do controllers call that? That's because a controller wants to control whether the things in its view recognize certain gestures. They might want to turn off certain gestures or not turn on certain gestures. So the controller is often controlling that. But occasionally you do get a UI view that will add a gesture to itself, like scroll view. Because a scroll view without the pan gesture or without the pinching gesture, if it can zoom, is not even a scroll view. In other words, that gesture is so fundamental to what a scroll view is that scroll view adds it to itself. It has some API to turn it off, but it adds it to itself. It doesn't make some controller add this gesture. It just recognizes pan and pinch. So mostly it's done by controllers, though you'll see that. The second thing, the handler, okay, that could either be the controller or the view, and what it really depends on is whether the gesture affects the model or whether the gesture affects just the view. Okay? If the gesture only affects the view, then the view will probably handle it. But if the gesture affects the model directly, now the controller has to handle it because the view can't see the model. Does that make sense? Everyone got that? So the handler is either controller or view. And you'll see that in the demo. I'm going to have one handler that's a model one and one that controls view, and you'll see where we put them. All right, so what's the code look like to add a gesture recognizer to a view? So for my example here, let's say I had a view, and this code I'm going to put here, by the way, is going to be in a controller. Let's say it has one of its views that it wants to add a pan gesture. A pan gesture is put your finger down on the screen and move around. Okay, that's called panning around in the view. Okay, so this is what it looks like. A good place to add a gesture recognizer is in the did set of an outlet for that view, because that's as soon as you can get a hold of it anyway. Your iOS just set that outlet up for you, so now you've got a hold of that view, so now you can send a message to that view, add gesture recognizer. So here I have this var, this outlet, called panable view. This is the view that I want to add the pan gesture to. And you can see that in its did set, in other words, when iOS wires this up, I'm going to do this add gesture recognizer. First, I'm going to create the gesture recognizer. Okay, notice I'm saying UI pan gesture recognizer, in the initializer for that, not UI gesture recognizer. I'm creating a concrete gesture recognizer, which is for panning, and that it has 2 arguments. Both these arguments are the handler, how this thing is handled. The target is who's going to handle it, and the action is what method is going to handle it. Okay? So now, in the case here, the target, I'm having the target be myself, the view controller. This is obviously in a view controller because this is in an outlet property observer. That would only make sense in a view controller. And so that target is myself. I'm going to ask, when this pan gesture starts to be recognized, it's going to be sending me the action here to handle it. And the action, you notice you have to say hashtag selector to specify the method. Don't get confused with the difference between a function type, a type that is a function, and an actual method in a class. Okay? We use hashtag selector to say this is a method. I want to call this specific method in my class. And notice I've said viewController.pan subRecognizer. Well, that means that the method that's going to be called is called pan, and it has one argument whose external name is recognizer : Okay, that's what that means. The viewController dot means that method is in myself. Now, if it was in my view, it would probably be like panable view dot whatever. This could also be self.pan. That's allowed, saying pan recognizer in myself. Also, you could omit that part totally and just say pan recognizer : because the default is for it to be in myself. So there's three ways I could have specified that: viewController.pan, self.pan, or just pan. Okay? But notice it does have that argument, by the way. That argument is going to be the recognizer passed back to me. So when the pan starts to be recognized, it's going to call this method, and the recognizer is going to be passed. This pan gesture recognizer, called pan gesture recognizer right there, that's going to be passed back to me each time. Now I've got a gesture recognizer for panning. I just add it to the view. Only views are capable of recognizing gestures. Okay, so if you have a gesture recognizer, the only add gesture recognizer method in the entire UI kit is in UI view, so you have to send it to UI view or a subclass of UI view. Okay? All right, so now let's talk about the handling. So now this is code adds the handler so that the view is going to start looking for pan gestures. Okay? And then when it finds them, it's going to start calling this pan recognizer. Okay? Now, before we can look at the code for that, we've got to understand a few things about it. Okay? One is that when you get a gesture like a pan or a pinch, you need some concrete subclass specific information about it. Like a pan, you got to know where it is, or a pinch, you got to know how much you pinched. Okay? So we have to understand what that means. Now, for a pan gesture recognizer, there are three, there's actually a little more, but there's these three very important pieces of concrete information about the pan. So translation in view is a function in the pan gesture recognizer where you can ask it, how far has this pan moved since it started? Okay, how far has it moved from the start as I'm moving around? Okay, X and Y. It's a CG point, so it's giving the X and Y where it's moved to since it started. Velocity says, how fast is the finger moving? Is the guy whipping it around, or is it going really slow? Because if it's going really slow, maybe you want to do very small drawing, and if he's whipping it really fast, you just want to, move something around. Who knows? And then there's set translation. Now, this last one is kind of cool because if you just know the start point and where it's moved to, you're not really getting the incremental move with each time you update. So you can actually set that translation to 0, and then instead of getting the distance from the origin, you're getting from the distance from the last time this was sent to you. Because this handler is going to be sent to you over and over as the pan moves around repeatedly, okay? Hundreds of times as you move around. So often you'll want to set that translation back to 0. It gives you incremental panning, okay? And you'll see that with some of the other concrete ones as well. Now, the abstract superclass UI gesture recognizer, even though you don't make one, it still is the superclass of these things, and you do inherit especially this one very important var called state. The state tells you the state of the gestures, how it's being recognized. So all of these gesture recognizers start out in the state possible. It's possible this gesture could happen. And then once it starts, if it's a continuous gesture, like a pan or a pinch, you go to the state began. Okay, so the system's like, oh, a pan, I think it started. So you'll get, your handler is called, and you can look at the state of the recognizer and say, oh, it began. And then every time the finger moves, it's going to get changed. It changed, it changed, it changed, change. Okay, you're getting your handler called repeatedly, and the only thing that's changing is those methods above, translation, and also the state moves to change. And then when the finger goes up, you get ended. Okay, you'll get your handler called, and the state will be ended. Now, for a discrete gesture like a swipe, Okay? The swipe either happened or not. When you're looking at a swipe, you don't get, ooh, the swipe started and it's moving across the screen and it comes up. No, either the swipe happened or not. So you just get called once and the state is going to go straight to being ended or recognized. Okay? But you have to be a little bit careful of the states failed and canceled. Okay? Failed might be because you started a gesture and then the system realized, oh my gosh, that wasn't a pan gesture. That was the start of a swipe or something like that. Okay? And so it switches to a swipe. So you can have canceled. And then the other one, it failed. And then you also can have canceled. Okay? You're in the middle of panning, phone call comes in, takes over your screen, person says, hello, how you doing? Okay, well clearly that pan gesture was canceled. Okay, so you could get that as well. So if you ever do anything when your gesture ends, then you have to be careful to clean up when it fails or gets canceled as well. Okay, so that's the state. So let's take a look then, knowing what we know about pan gestures, what the handler would look like. So remember that the handler is called pan. Recognizer is the argument there, and that is the pan gesture recognizer itself coming back to us, and its state will be different, and we can ask it about translation and view and all those things. So the first thing we're going to do is look at that state, and I'm going to do the same thing whether the pan has changed or whether the finger went up. You know, that's kind of the last position of the pan. I'm going to do the exact same thing. Notice, by the way, I'm using this switch thing fall through. Hopefully you got that in your reading assignment. That basically just means that you want to fall through to the next case, because in a lot of languages that's the default, but in Swift it's not the default. You don't fall through. So fall through makes you fall through. It's a special keyword. You could also just say case.changed, .ended, : That would probably be actually better. We'll do that in the demo. All right, so if the pan moves a little or it ends, then I'm going to get the translation from where we started at first by asking for the translation in the pannable view. That's the view that the panning is happening there. Okay, you're almost always going to ask for the translation in the pannable view, but you could ask for it in other views and it will convert to that other view's coordinate system if you want. But almost always you're asking for the one in the pannable view. Then I'm going to take that translation, that amount it moved, and I'm going to go do something in my app. You know, draw a line to if I'm tracking the finger with a line, or if I'm moving something, I'm going to move the thing to the new position. Then if I want, I can set translation to 0 so that the next time this handler is called, the translation is going to be just the distance from the last time it was called, okay, as opposed to the distance from where it all started, right, where the pan started. Okay? So that's it. That's how a handler works. It's easy. Let's talk a little bit about some of the other concrete gestures. There's pinching. Pinching is going to give you the scale. So I put my fingers down, 2 fingers on the screen, and now the scale is 1.0. If I put my fingers twice as far apart, now the scale is 2.0. If I go down to half as small, now the scale is 0.5. Okay? So that's what pinch is doing. It's just constantly reporting what the scale is relative to what the pinch started. Now, that scale is not a read-only var. So you can reset it as well, and then you'll get incremental scale, how much the scale has changed since the last time. In other words, it's almost like you keep resetting the initial finger down to scale if you set that scale to 1. Okay? So that's how you can get incremental scale, and we'll do that in the demo as well. And you also get velocity, okay? How many points per second or whatever this thing is, or not points per second, it's really scale factor, okay? The percentage scale is changing, how fast it's changing per second. There's also a rotation gesture. That's 2 fingers down, like turning a knob. Okay? Keep the 2 fingers down, you turn them. You get the rotation there. That rotation is in radians. Okay? Again, not read-only, so you could reset it and get the incremental turning. And you also get the velocity in radians per second, how fast the person is turning their knob. There's also a swipe gesture. Again, this is discrete, so your handler is only going to be called once if it recognizes this gesture. Now, because of that, you have to configure a swipe gesture recognizer. You create it, and then you want to set vars here like direction. Do you want a left swipe, right swipe, up, down? And how many fingers? 2-finger swipe, 3-finger swipe, 1-finger swipe? You set all that up when you create it, because then it's just going to be looking for that, and when it finds it, it's going to call your handler once, okay, because it's discrete. And then there's tap gesture, similar to the swipe gesture, in that you have to configure it. Number of taps, like is it a double tap? And is it 2-finger tap? Whatever. You do that, and then it's going to call. This is not purely a discrete gesture like swipe gesture. Really, you're looking for the state ended with a tap as well, but it's still, you have to pre-configure it like a swipe, so it behaves almost exactly like a discrete gesture. Okay, so hopefully this will all make a lot more sense when we show it in a demo here. Our demo, we're going to add 3 gestures. One is a pinch. That's just going to make the face bigger and smaller, okay, which has nothing to do with our model. That's view only, so we're going to put that handler in the view. And then we're going to do pan, moving around, okay? Actually, no, we're going to do swipe instead of pan. Let's do swipe. We'll do swipe, and we're going to use swipe to make our face happier, or swipe down to make it sadder. And we'll have tap to open and close the eyes. How about that? Okay, and those last 2 are obviously going to affect the model, so they'll have to be handled by the controller. All right, so let's go back to our code where we were here. And how are we going to do this? Let's do the pinch first. Okay, now the pinch doesn't affect the model, so it can be handled by the view. So let's actually go over to our view and start by writing a handler for a pinch. Okay, I'm going to call this handler func change scale, because that's what it's going to do. It's going to be a pinch, right? So it's going to change the scale of our head. And I'm going to say by reacting to a pinch recognizer, which will be a UI pinch recognizer, pinch gesture recognizer. There we go. Okay, so this is going to be my handler. Okay, so it's going to get this pinch sent back to me all the time, and I'm going to look at that pinch's scale to know how much to scale my own scale. So I'm going to switch on the pinch recognizer's state. Remember, it inherits that from UI gesture recognizer, which is the superclass of this. And in the case that it is changed, okay, so the pinch has changed, or if it's ended, which means the user lifted the fingers off, okay, in either of those cases, I'm going to adjust my scale by whatever the scale is of the pinch recognizer. Simple as that, just times equals. Okay? Now, the thing about this though, what if I start my pinch here at 1.0, okay, and I move it just a tiny bit? Okay, fine, my scale gets moved just a little bit. What if I move all the way out to scale 2.0? Okay, now my face gets 2.0. Now what if I move it out to 2.1? This code's going to make my face go from 2.0 to 4.2. You see? So I need to keep resetting this scale back to 1 all the time, so I'm getting incremental scale changes. So I'm going to say pinch recognizer dot scale equals 1. So I'm just constantly reset it. Every time this gets called and I move my scale up, I'm going to reset the scale so that I'm starting at 1 again with my pinch. Okay, that gives me incremental scaling there. And of course, we have to handle all the other cases of the state, but I'm not going to do anything. So I'm not going to do anything when the pinch starts. If it gets canceled, I don't care. I'll just leave it whatever scale it was in at the time, et cetera. So I don't need to really handle any other cases. So that's it. The handlers are super easy to write. Okay? And this scale, by the way, everyone understands, is this scale right here, this var. It's our scale. Right? Question about that? Okay, so now we have a handler. We have someone to handle when a pinch happens in the view. Now all we need to do is add a recognizer that recognizes a pinch and calls that handler. So we're going to do that up here in our face views did set, okay, because this is the first time we got a hold of that face view, and I want the face view to be the one that is recognizing this pinch. So let's start by creating the handler. So I'm going to create a little local variable just to make it clear to my handler. It's a hashtag selector, and it's the face views method change scale by reacting to. Okay, that's my handler. We got that? And then I'm going to create a recognizer here, a pinch recognizer, and it's going to be a UI pinch recognizer, gesture recognizer, and of course we need the target and the action. That's all we need to do to create a recognizer. So the target is going to be the face view. It's going to handle this thing itself. And the action is going to be this handler. Okay, that's it. Now we just need to take the face view and add gesture recognizer, the pinch recognizer. And by doing that, face view is going to start recognizing pinches. And when it recognizes one, it's going to send this handler message right here to the face view. Okay, let's see. We sure hope this is going to work. Let's see. Well, when you might ask, by the way, if I have a mouse here, how do I do a pinch in my thing? Okay, well, the magic there is Option. If you press Option, look, I haven't even touched anything. See, I have two things right there, and they kind of stay the same apart. You can also do Option Shift, and it'll offset them, so you can pinch anywhere you want. So anyway, you do that, and now I'm just going to hold the mouse down and pinch. Oh no, it's not working. See that? How could that possibly be? Well, let's take a moment here and debug this. Why would this not be working? I put that pinch gesture, I added it, I have a handler. Let's start by going to our face view and putting a breakpoint right here in our handler, and let's see if it's actually handling it. Okay? So I'm going to go back to here. I'm going to get my option and ready, pinch. Oh, all right, it broke. Okay? It's definitely calling my handler. So what's the problem? You know, let's do another thing. Let's print our scale and see if our scale is being changed. Okay, I'm just going to put a little print in here and use a combination of breakpoints here and doing print debugging. And let's see if the scale is actually being changed. All right, so here we go. Again, Option key, and oh, it looks like it is. I see something in the background there. Sure enough, look at that. Half. Double, oh, it's working perfectly. Why is it not redrawing that face? Can anyone think why it's not redrawing? Because we know it's working. It's because when you change a var, okay, like scale right here, it does not automatically know to redraw your view. Okay? That scale is changing fine. But the last time draw was called was when this first thing was drawn. You know this method we have down here in the face view called draw CG rect? This thing? This was called when it was first drawn, and it's never been called again. So, you know, without this being called, there's no other way to draw my face. I told you this is the only way to draw. So we have to get this to get called. And how are we going to do that? Well, we're just going to slide right up here to scale, and anytime scale gets called, we're going to do a did set. Okay? And inside here, we're going to cause ourselves to get drawn. Now, how do I do that? Do I call draw like that? No. I see a lot of shaking heads no, and absolutely not. Of course, we never call draw, or we get huge trouble if we do that. What do we call instead? Anyone remember from the slides? Set needs display. Okay? So we're telling the system something about us has changed. We need to be redisplayed. So please, at your earliest convenience, redisplay us. Okay? And that's what it's going to do. And in fact, we want this on all of our things here. Right? Anytime any of these public things get changed by someone, we want to redisplay. Let's put this comment up here. Okay? So this is very common to have this little snippet of code after any var that when you change it would change the way things look. Now when we run, we can actually go back here and get rid of this print because I'm pretty confident it's going to work now. Okay, here we're going option again, and sure enough, look, our scale. Since our scale changes here, that set need display is asking to draw, and iOS is accommodating us by drawing. Okay, that's pretty cool. That was quite simple to put in that gesture to do that. So let's go back now to our controller and think about doing a gesture like a tap to open the eyes. Now again, the view could be the handler for that. Our view knows how to open and close its eyes. But if we made the view be the handler for a tap and it opened the eyes, it would get out of sync with the model, right? Because the model is what says whether the eyes are open, not the face view. The face view is the slave. It's a minion of the controller. It's supposed to do what the controller wants. So we can't do that. So we're going to have the controller handle a tap and change it in the model. And then it'll automatically update in the UI because of this line of code right here. Anytime we change our model, it's going to update our UI, right? So we're just going to have a handler for tap that just changes our model and everything. That's all it needs to do. Okay? So let's write that handler first. Let's call that handler, how about toggle eyes? Because we're going to tap and it's going to toggle the eyes. If it's open, it's closed, closed, it'll open. Okay? And toggle eyes is a tap just recognizer based thing. So I'm going to say by reacting to a tap recognizer, which is of type UI tap gesture recognizer. And here I'm just going to say if the tap recognizer state is ended, so the tap happened, then I'm going to let eyes, which is a facial expression.eyes, just so that you know what type that is, equal whatever my current expression's eyes are. If the current expression's eyes are closed, then I'm going to have them be open. Otherwise, they'll be closed. So I'm just toggling them. See that? So eyes now, which is of type facial expression.eyes, right? It's got the opposite of whatever the old one had. And so now I'm going to set my model to equal a new facial expression. And that new facial expression's eyes are going to be this new eyes I just calculated. And the mouth is going to be whatever the old mouth was. I'm not doing anything to the mouth, so I'm just going to say expression.mouth for the old one. So here I'm changing my model, and that's going to cause this did set to happen. It's going to redraw my view, and the eyes are going to be the opposite of what they were. Everyone got that? So that's the handler. That's going to handle it. So now we have to add a tap gesture recognizer to our face view. So this time, let's just say let tap recognizer equal a UI tap gesture recognizer. And always we just specify target and selector. So the target this time is not face view. Up here it was face view. Now the target is myself. And the action is going to be, again, I can say face view controller, or I could take self dot. We'll do that. Toggle eyes. Okay? And we need to put around this hashtag selector, right? Because we need to turn it into that particular selector. Okay? And again, I don't actually need that self in there. I could just do that. It looks a little better because it defaults to my own methods. Okay, so we got the tap recognizer created. Now we need to configure the tap recognizer because we want it to happen on single taps. So we could say, for example, number of taps required equals 1. That happens to be the default, so probably wouldn't need to actually say that, but we'll do it anyway. And now we need to turn it on, and we do that by adding a gesture recognizer to the face view. Okay? If you don't do this step of adding it to some view, then that view is not going to be recognizing this. So it's not going to be doing anything. Okay? So this is an easy step to kind of forget. All right, so let's see if that works. All right, so tap. It's working. Okay? Every time I tap, it opens and closes the eyes. And it's changing it in the model, right? So changes in the model, that causes this update UI happen. This update UI does this little thing to update the eyes. When it calls eyes open over here, okay, eyes open, when it gets set, it calls needs display, which causes the thing to redraw. Everyone got that chain of events? Okay, let's do one other one here, which is to do a swipe. So I'm going to have a swipe where swiping up makes our face happier, and swiping down makes it sadder. So I'm going to have, this has to be handled in the controller. Why? Because this is affecting the model. The happiness is in the model. So I'm going to have a func called increase happiness. Okay? And it's just going to set the expression equal to the existing expression, but happier. Okay? And I'm going to do a func decrease happiness. It's going to do the opposite. Expression equals the current expression, but sadder. And these vars here, happier and sadder, those are in the facial expression right here. Okay? You can look at those later, see how they work. But basically, they're just creating a new facial expression where the mouth is happier or the mouth is sadder. And then the mouth knows how to be happier or sadder. It's using this raw value mechanism in enum. Hopefully, you figured that out in your reading assignment. This is a great opportunity to go figure it out if you didn't. Okay? So back in our controller here, we now have these handlers. Notice these handlers have no arguments. Why do these handlers not have an argument, like this by reacting to guy down here? Because a swipe gesture is discrete, so we never have to look at the swipe gesture when it happens. We know it happened, and that's all we need to know. So these handlers do not ever need to look at the state or anything like that, like a tap gesture or a swipe gesture or a pan gesture. All right, so let's add these guys to there. So I'm going to let swipe up recognizer equal a UI swipe gesture recognizer. Whoop, not switch. Swipe we'll learn about that later too. UI swipe gesture recognizer. Again, target in action. Again, the target is myself because it affects the model. And I'm going to have this be the selector increase happiness because this is swipe up. Okay. Now I have to configure it. Swipe up recognizer's direction is up. And now I'm going to add it. FaceView.add gesture recognizer, the swipe up recognizer. And since swipe down is so similar, I'm just going to copy and paste here. Copy, paste. And we will change swipe up to be swipe down. Copy, G, paste. And of course, the direction here now is down, and it's decrease happiness instead of increase. Okay, so I've added these two recognizers, up and down swiping, and they're going to increase and decrease our happiness in the model. And when the model changes, update UI gets called. We're going to look up the mouth curvature in that dictionary. We're going to set the mouth curvature. That's going to do the did set. We're in good shape. So here we have a pretty sad guy. We'll open his eyes, and we'll close. Now we'll leave him open, okay? And now we're going to make him happier and happier and happier. Woo, he's really happy. And swiping down, oh, no, not so happy after all. Okay? Everybody got that? So that's it for gestures. Gestures are super simple and super powerful because all the logic going into detecting, was that a swipe or was that a pan or what was that, is all done for you by iOS. All right? Okay. Back to our slides, which are right here. All right. Time to talk about building bigger apps. Apps where we're going to have multiple MVCs involved, not just our calculator MVC, but multiple MVCs, not just our face view controller MVC, but multiple MVCs, okay? So I showed you this picture from the MVC discussion, and you can see that the MVC's relationship to each other is that one or more MVCs is part of the view of another MVC. So let's see how that happens, okay? We combine these MVCs using kind of, I don't want to say special because you could write your own, but built-in MVCs that come with iOS. And these MVCs are built using other MVCs as part of their view. So, yes, you can build your own. So, for example, here's the three that we do most of our building with here, or pretty much all of our building multiple MVCs. There's the tab bar controller, a split view controller, and a navigation controller. So I'm going to go into detail here about how each of these controllers are controllers of MVCs whose view is other MVCs. Okay? So here's tab bar controller, for example. If you look at what you see up there, there are two MVCs on that screen. Two. One MVC is the tab bar controller. It's what's drawing the little icons at the bottom. You see those icons at the bottom, those four icons? Okay, that MVC is doing that. The other MVC is the thing surrounded in yellow, a dashboard MVC, whatever that is, something in the health app here or something. That is drawn by a completely different MVC, the dashboard MVC. But notice how it's drawing inside the view of the tab bar controller. So you're already seeing here how we're building an MVC out of other MVCs, okay? The tab bar controller has an MVC built into its view. Now, what's interesting is that this is very object-oriented in that those buttons along the bottom, both the icon and the text on it, and if they had a badge, that would be there too, those are actually not being set in the tab bar controller. The tab bar controller is grabbing them from the MVC, dashboard MVC. Okay, it grabs them from a var in the dashboard MVC. It's a UI view controller var called tab bar item. And tab bar item has things like badges and titles and icons, things like that. Okay? And of course, we can have more MVCs in the tab bar. If I click on that second icon right there, I get a different MVC filling up the space at the top. So now we've seen three MVCs so far: dashboard, health data, and the tab bar controller. Right? Now, by the way, if you get too many tabs, if you put 6 MVCs, for example, into a tab bar controller, then you get a little more ... icon on the right, and you can click that, and the user can get at those. So a tab bar controller could have more than 5 MVCs, okay? But if you start getting more than 5, the UI gets a little clunky because their users having to go over and click that more to get to the other one. So I kind of recommend if you have a tab bar, don't put more than 5 MVCs in it. So the question is, when we have the icons at the bottom and the icons and the titles there, and I said that it's getting that from the MVCs that are being shown. The question is the dashboard MVC like the health data MVC, or sorry, is the embedded MVC like the health data one or the dashboard one, is it getting the button and the title there from the model? And the answer is that's up to that MVC. Some MVCs might well do that. Probably most are not, because it's kind of more of a UI thing, what the icon and what the text is. Probably not part of the model, especially the icon. It's unlikely to be in the model. Okay, so does that answer your question? All right, so and of course we have more MVCs for a total of 5 MVCs on the screen. Okay, the tab bar controller and these 4 MVCs that are each of the tabs. So this is the simplest way to combine MVCs. But do you see what I mean when I say that these other MVCs are part of the view of the tab bar controller? Okay, they're actually their views are embedded, physically embedded inside the tab bar controller's view. Okay, so that's the simplest one. Let's talk about the next simplest one, which is split view controller. So split view controller is 2 MVCs side by side. Okay, you get to see them both on screen at the same time, at least in landscape you do. This one on the left here is a calculator MVC. Doesn't look much like yours, but you can imagine that's a calculator MVC. That MVC we call the master MVC of the split view controller. Okay, and then on the other side, there's a whole different MVC, completely and utterly different. This one happens to be a calculator a graph of what's in the calculator MVC. And this is going to look very similar to your homework assignment, because that is assignment 3, okay, to build a graphing calculator. And you're going to be putting in a split view and doing all the things I'm talking about today, so pay attention. So that one we call the detail. The reason we call that a detail is almost always the right side, which is larger usually, happens to be, whatever's in it happens to be controlled by what's on the left side, the master. And that would be true here, right? Because the graph on the right is showing whatever is in the calculator on the left. So if you change something in the calculator on the left and hit its graphing button, whoop, it changes the detail. So the detail is, the master is controlling the detail in that way. Now, this is what it looks like when these things are side by side in landscape mode. But what if you switch over to portrait? Well, in portrait, it just shows you the detail. But you can swipe from the left, okay, and get the master to come out on top of it. And then do whatever you want, still updates the detail, and then you can swipe it out of the way. All right? So that's split view controller, super simple. Again, hopefully you're seeing that there are 3 MVCs up here. The split view controller's MVC and these master and detail MVCs. So the master and detail serve as the view of that split view controller. Notice that the split view controller itself has no UI. It doesn't actually draw anything in its view. It just uses the UI, or the view of these MVCs, to draw. I guess it draws the vertical line between the two. That's probably drawn by the split view. All right, now the most complicated one, and the most commonly used one, is a navigation controller. Okay, another MVC that uses other MVCs in its view. All right, so here we see 2 MVCs on this screen. Navigation controller based MVC, and it's showing this another MVC, which I'm calling the all settings MVC. All right, now in this particular view that you're looking at, see on the top there's a gray bar that says settings in there. Okay, the gray bar, which is actually transparent and is showing the all settings MVC behind it, kind of fuzzed out a little bit. That gray bar is drawn by the navigation controller. It and a toolbar on the bottom, which I'll talk about in a second, that's the only thing that the navigation controller actually draws in its view. The rest of its view, it fills up with another MVC, okay, the view from another MVC, in this case, the all settings MVC, all right? And so the contents are all this all settings MVC. Now, just like with the tab bar controller, where there was that tab bar item that had like the icon and the title and all that, same thing with the navigation controller. That word settings at the top, the navigation controller MVC is getting that word by asking the MVC that it's currently showing, what's your title? Okay, now it gets that from this var navigation item. Okay, it's a UI view controller thing, just like tab bar item has all the tab bar things, navigation item has all the navigation, UI navigation things. So if you look at the API for navigation item, it has things in there like title. And I'm going to show you another property that it's going to use in a second to get more information to draw. All right, so if I click in this table view, actually, if I click on General right there, then a new MVC is going to slide in on top of that All Setting Ones. Now the All Setting Ones is completely non-visible, but it's still there. This is like a stack of cards where I've put a new card on top. The other card is no longer on screen. Okay, you won't see it anymore. It's gone. Okay, but it still exists in memory in the navigation controller. So now we have 3 MVCs involved in this navigation controller. The navigation controller's MVC, the all setting ones that is now in the back of this one, and this one, the general settings MVC. Okay? Now, by the way, you can have toolbar buttons along the bottom here. Okay? They look similar to the tab bar ones, but they're a little different. That is set with the toolbar items var in the general settings MVC, not in the navigation controller. Okay? So as new MVCs slide in, the toolbar buttons at the bottom would change because they're connected to whatever happens to be on top of the deck of cards. Okay? Now, if I and notice also there's a back button. You see that back button? It's called Settings. Okay? That button was automatically put there by Navigation Controller. And if you click that, it's going to go back to the other card, the All Settings. So that's all done for you. All right? But if I click somewhere in here, like on Accessibility there, then it goes to another MVC. Okay, now we've seen 4 MVCs so far in this thing. And if I click on larger text in here, I get yet another MVC. Now we have 5 MVCs, right? So these MVCs just keep stacking on top. And each of the new one that comes on is its own world. It's completely on its own, okay? And of course, if we start pressing the back button up there on the left, it goes back to the previous one. Notice the title of the back button is even set to be the title of the previous MVC, so you know what's going to happen when you click it. Okay? And we can go all the way back to the All Settings at the very top. Now there's no back button because there's no other cards. So that's what a navigation controller looks and works like. Okay? You guys have all seen this UI, I'm sure, in apps. Super common. So let's talk a little bit how the navigation controller works behind the scenes. Okay? How you make this thing work. So when do you need a navigation controller? Well, let's say you have an MVC right there, and you got another whole pile of UI down here in the corner that you want to add, but just won't fit. Okay, you want to be able to do the accessibility stuff and the larger text and all that we saw on the previous slide, but it obviously is not going to all fit in one phone screen, so you need more space. So what you do is you create a new MVC that controls all that UI that is completely independent of that. Okay? And it just knows how to manage that. Now, they might share a model because maybe they're all looking in the settings database. That's fine. But they're not talking to each other in any way. The only time they ever talk to each other is when it first comes on screen, as you'll see in a moment. Okay? So I've got 2 MVCs now to control all the UI that I want to present. So let's use a navigation controller to make these come on screen. And so here's a navigation controller. It's just an MVC. Okay? It doesn't really have a model. That's okay, but it has a view. And inside that view, there is a special var that points into its view called root view controller. That just points to the controller of the MVC that's at the root. It's the base card, okay? The all settings one we saw on the previous page. Okay, so it just has this var. You just set that to something, and now you'll have an MVC. And as soon as you do that, as soon as you set that, it's going to take that MVC's view and put it in its view with that little gray bar, and it's going to ask it navigation item for the title and get the title, right? Perfect sense. It's super simple. And then let's say you have a button inside this UI or like a line in the table view, like get me more settings or accessibility or whatever, and you touch that. Now when you touch that, it's going to create one of these MVCs on the right. It creates it at that moment. As soon as you touch it, it creates a new one. Every single time you go to a new card, it creates a new one. Not back, but every time you go forward to a new card, always creates a new one. That's something I'm going to say 3 or 4 times in this slide, so you make sure you understand it. Okay? This activity of going to new one is called segueing. Okay? And this particular segue is called a show or a push segue. Okay, which just means a segue in a navigation controller with a stack of cards. Now, when you do that, you get the back button for free. It just automatically appears up there because that top bar, like I say, is drawn by the navigation controller as part of its view. And when you click that back button, of course, what happens is interesting here. Of course, this slides back, but what happened to that MVC? Gone. Deallocated from the heap. Okay? So when you go back, whatever card was on top gets thrown away. So MVCs, as you're kind of getting a picture here, they're pretty ephemeral, right? MVCs don't really stick around for a long time. Now, the root card on a navigation controller is going to stick around pretty long as that navigation controller is on screen. But mostly MVCs kind of come and go. And it's their models that tend to be persistent, right? When you create a new MVC, you usually hook it up to a database or a network or something persistent. And so that's why it's showing something new. Or it's an MVC that shows something new every time. All right, so that's how a navigation controller works. So, I'm going to talk a little bit how we hook all this up, because of course we're going to do all this hooking up with control drag in Xcode. That's how we hook everything up. So, but I want to talk a little bit about the code behind, so you know. There's an important var that is in these view controllers, like tab bar controller and navigation controller and split view controller. It's called view controllers, and it's an array. It's an optional array of UI view controllers, and it means different things depending on which one you're in. So, for example, in the tab bar, this is all the MVCs for each tab, with the leftmost tab's MVC at 0, and then 1, 2, 3, 4 is just the rest of the MVCs. Okay, for a split view, 0 is always the master, 1 is always the detail, and there's never any other ones in this array. For navigation control, 0 is the based card, and 1, 2, 3, 4, etc. are the ones stacked on top in order. Okay, so that's how you can kind of get at them. Now, we don't usually, this is a var. It can be set, but we usually don't set this var. We don't set the things. We either use things that we do in our UI, which I'll show you, or even like in navigation controller, there's push and pop methods to push MVCs on and pop them off of the stack. Now, it's great to have this var view controllers, but how do you get the split view controller or get the tab bar controller if you're in one? Okay, if I'm the all settings MVC, or I'm the one of the health data ones that we saw on the tab bar, how do I get the navigation controller I'm in, or the split view I'm in, or the tab bar I'm in? Well, all UI view controllers have these three vars: tab bar controller, split view controller, navigation controller. And if you are in one of those things, this will return the one you are in. And if you're not in one, it will return nil. Okay, so that's how you find out the split view controller you're in. And you can use the combination of these two things. For example, if you're the master in a split view, you can find your detail MVC by saying, what's the split view controller I'm in? Get its view controllers, look at view controller sub 1, because that's always the detail. You see? So I just quickly went up and over and got it. And I use the question mark, the optional chaining there, because I might not be in a split view controller. Then it obviously will return nil for my detail, which is fine, because it would be nil. If I'm not in a split view controller, obviously there's no detail. Okay? Now, how do we wire all this stuff up? Of course, we're going to do it all graphically. Let's start by looking at the split view and how we do this. Now, to create a new view controller, whether it's one of these view controllers of view controllers that we're talking about, or just a regular view controller, you go down to the object palette and you drag it out into your storyboard, just like a button, okay? Except for you just drag it into open space and it creates it there. Now, when you drag a split view controller out, it's actually going to drag out kind of empty detail and master, okay? You never want that. I don't know why it really does that. Just delete those, okay? Because you're obviously going to have your MVCs, like your calculator and your graphing view controller, sitting there in your storyboard, and you're going to drag the split view out controller, and you want to wire it up to those, okay? So you're going to delete any of the extra junk that comes out. Then you just control drag, like we do. Our favorite gesture in Interface Builder is control drag. We just control drag from the split view controller to the master and to the detail to hook it up. So this is what that looks like. Here I've got a split view controller on the left. I've got a calculator view controller on the top, and I've got a graphing view controller on the bottom. So I'm just going to control drag from the split view controller to the calculator controller. This little black window is going to come up. I'm going to choose master view controller from the list, and that's going to hook up that one on top to my master. Then I'm going to control drag to the bottom one. The black window comes up. I'm going to choose detail view controller, and it's going to make that connection. Okay? As simple as that. Now you've got a split view with master that's a calculator, view controller, and detail that is going to be a graph view controller. Now, one interesting thing here, though, is that a split view does not work on an iPhone. Well, it works on iPhone Plus, okay, iPhone 6 Plus and 7 Plus, the kind of big ones, but it does not work on a normal iPhone. It's just not enough screen real estate to really do the split view thing, so it can't do it. So what we really want to do is build a UI, though, that works on all the devices. So to do that, what we do is we're going to wrap the master and the detail if we want. We're going to wrap them in a navigation controller. And then when they're on an iPhone, they won't use the split view part, they'll just use the navigation controller. So it's really cool how it figures this out. So the way to wrap a view the controller that's in there, and you want to wrap it in a navigation controller, you just go to the editor menu, the same place we did embed and stack view and stuff like that, and you select the whole scene of your MVC, and you go to the editor menu and you say embed in navigation controller. So I've selected that top calculator controller, and when I do that, it's going to put it inside a navigation controller. See that? So now I've got the split view, it points to a navigation controller, so the master of the split view is actually that navigation controller, and then that navigation controller's root view controller is the calculator. So if you're on a device that can do split view, like an iPad or a Plus, you're going to get the whole split view effect. But if you're on just an iPhone, it's not going to do the split view, it's just going to do the navigation controller. So when you look at the detail, it's going to slide it in. Whereas if you're on a iPad in landscape, you're going to see the master and detail at the same time. Now you can also do the same thing. Oh yeah, and so the UI navigation controller, yes, is the master as I talked about. So you can do the same thing with the detail. Now why would you ever do that with the detail? Because you've already done it with the master, and so you got to click in the master to get to the detail, so you're kind of already going to be in a navigation controller, and that's true. But what's kind of nice about putting the detail in a navigation controller is you get that little title bar. You know, the little gray title bar. So now your master and your detail both have a title bar along the top, and they match up nicely. So if you want a title on your detail, that's a good thing to do. The only thing to be careful there, though, is now your detail is not a graph view controller. Your detail is a navigation controller. So if you want to get the graph view controller and like talk to it, tell it what to graph or something like that, you need to get the root view controller of the navigation controller. You see what I'm saying? So it's just a subtle difference, but if you wrap your detail in a navigation controller, the detail has become a navigation controller. It's easy to get to the graph view controller because it's the root view controller of the navigation controller, but still. All right, so that's how you wire up the split views so that it works cross-platform, all devices. All right, the last thing we're going to talk about is segueing. So we know how to wire up like the split view controller, and we know how to do a navigation controller. We just embed it in the navigation controller. I didn't talk about the tab bar controller, by the way, but that's easy. You just drag a tab bar controller out and control drag to all of the MVCs that you want it to show. And you can actually even drag the little icons around to put them in order. You can even set the icons and text in the interface builder with an inspector. So tab bar is so simple, I don't even waste time showing it. But so we know how to kind of hook up and control drag to wire up or embed to do the navigation controllers. But how do we go from one to the other? Like on the navigation controller, how do we go from all settings to settings, and from settings to accessibility, and accessibility to larger text, right? How do we set up that transition? Or how do we make it so that we press a button in our calculator in a split view and it causes that graph to be replaced with a new graph? Okay, how do we do that? We do that with what are called segues. Kind of alluded to this earlier. All right, and these are the kinds of segues that exist. There's a show segue. That means you're in a navigation controller, slide a card on. Okay. There's show detail, which if you're a navigation controller still means slide a card on. But if you're inside a split view, it means put this new MVC where the detail goes. That's why it's called show detail. So show detail behaves differently depending on whether you're in a split view or you're in a navigation controller. Modal segue, it's kind of an interesting one. It takes over the entire screen and lets the MVC that you're segueing to own the whole screen. Now, these can be somewhat disturbing to the users because like, I can't get back to where I was because there's no back button or anything. That whatever MVC comes up and takes over the screen has to provide some UI to get out of there, like cancel or done or something. So we try to stay away from modal if we can, okay? And then popover is really the same as modal, but instead of taking over the whole screen, it just puts up a little pop-up window, a little pop-over window. You've seen that on iPad especially. But it's still modal because if you click anywhere else, the pop-over goes away. So it's essentially modal. Okay? It's a little nicer than modal though, because you can at least see the background kind of grayed out. And if you don't want what's in the pop-over, you can just click somewhere else and it goes away. So the pop-over is a little nicer than modal, but it only works on fairly large screens unless you have a really small pop-over window. Okay. Now, I'm going to emphasize for the second time what I said before. Segues always create a new instance of the MVC. All of the segues. All of them, modal, popover, show, sliding them in, show detail, even show detail in the split view. If you have a calculator and you say graph my function and you segue to a graph view controller, it throws away the one that was there and puts a new one there, always creating new MVCs. So think of these MVCs as ephemeral. They come alive, they do their job, and they go away. They don't live long lives. Now the master and the split view, the root view of a navigation controller, they tend to live fairly long. But even those, if that split view or that navigation controller go off screen, they go away as well. All right? So how do we make these segues happen? Of course, we use control drag. We love to use control drag. So here, for example, is the calculator example. I got a split view. And in my calculator there in the upper right, I have a button. It's very hard to see, but it's a little picture of a graph. So that's the button that when I press it, it's going to take whatever's in my calculator and graph it. So if I've typed in, for example, m cosine, it's going to draw a cosine wave. Okay? That's what that button does. So I just go into Interface Builder here, control drag from that button down to the detail right there. When I let go, it's going to put up this little black window, which I'll show you a little detail of. It looks like that. And I'm going to pick the segue I want. Well, since this isn't a split view, if I can, I'm going to show detail, put it on the right side of the split view. Now, if I were in this same storyboard, but I was on an iPhone non-plus, then even though I'm picking show detail here, it's still going to do the navigation controller show because there is no split view side when I'm on the iPhone. Okay, so I pick the segue type I want, and it creates this segue. And it appears in your storyboard. It can even be clicked on and inspected. And in fact, you're going to always want to click on that thing and inspect it because you're going to want to set this thing right here, which is the identifier. Every segue has an identifier. It's just a string, and that identifier is what you're going to use in your code to talk about this segue. Okay, and I'll talk about what you can talk about regarding segues in a moment here. So always set that. And you want to set it, the identifier to be something that kind of says what this segue does. So in this case, it shows a graph. So I call this show graph. All right? So that's how you set up your segue. And that's true for navigation controller as well. If you have a navigation controller and you have a button that causes another card to slide on, you just control drag from that button to the other MVC. And then you use a show segue, and it'll just work. Has to be all embedded in a navigation controller, of course. But. So what can you do with these identifiers? It is actually possible to cause a segue to happen from code with perform segue with identifier, but I'm not even going to talk about that because we're never going to do that. We always are going to have buttons. Well, I'm going to say we're never going to do that, but we won't be doing that in your assignment 3, that's for sure. It's pretty rare. But you can do it with perform segue. But the more important use of the identifier is not causing segues to happen, because the segues kind of happen automatically when the buttons are pressed. It's to prepare for a segue. This is the most important method in all of multiple MVC programming, is this preparing for segue method, which I'm going to show you in a moment here. Okay? And remember, we're always segueing to a new MVC, freshly created, so it's always raw, so we have to prepare it to do what it's going to do. All right, so here's the method. It's called prepare for segue, and it also has a sender argument right there. The segue that's passed along, that first argument, is just a little container that contains interesting information about the segue. For example, the identifier, show graph, or whatever, and very importantly, the controller that you're segueing to. Because the whole point is here is you're supposed to be preparing this MVC that's going to come on screen to do its job, so you get that thing from this little segue object. The sender, it's kind of like buttons, the button sender when we had the action there. It's just what object is instigating this. So in the calculator example, you're going to have a button clicking, causing this segue. It's going to be that button, okay, the button that's causing the segue. But it's any because anything. You know, when we saw the example of the all settings, we were clicking on table view cells there, not buttons, but cells in what's called a table view, which we're going to talk about week after next. And so that could be the sender. Or you might have done perform segue on the previous slide. That actually lets you set the sender, so you could set it to anything you want. It could be nil also, all right? We don't use it that much. All right, so first thing I'm going to do is I'm going to get the identifier. Note that it can be nil, so I'm going to say if let to get it out of that segue right there. And I need that identifier because I need to know which segue I'm doing, because I might have 3 buttons on my calculator that segue to 3 different things. Now, you're not going to have that in assignment 3, but you could have multiple buttons segueing to different things. So you need to know which segue you're talking about. So you switch on it, and then you check the case. And in the case of show graph, okay, which is the one we're going to do right here, we're going to prepare that graphing MVC to do its job. Okay? Now, in order to talk to that graphing MVC, we have to get it as a graph controller. Now, the type of that destination view controller that's in the segue object is just UI view controller. Okay? It doesn't know that it's a graph view controller or something like that. It's just UI view controller. So we have to use as. Remember the as, and I told you could cast anything, not just any object. You can cast a UI view controller to try and downcast it to a specific view controller. So here I'm going to try and cast the destination view controller to be a graph controller. I'm going to assume the graph controller is the type of the controller of my graph MVC. And if I'm able to do that, which I should be, because I know this is the show graph segue, so I better be. If I'm not, then I want to raise an exception here, because I'm really expecting to be able to do it. Maybe I use as exclamation point right there instead of as question mark, because it'd be bad if I was doing this and it wasn't actually a graph view controller. But anyway, I get the graph view controller. So now VC, this variable VC, is of type graph controller. So I can start setting vars in it, calling methods, whatever I need to do to prepare that graph controller to do its job. Now, in the calculator case, what I'm doing is I'm going to somehow have to set the model of the graph view controller or something to show the graph I want, okay, based on what's in my calculator. So I'm preparing it to do what it does. Now, I'm pretty much never going to talk to this thing again. So I got to give it all the information it needs to do to go do its job, okay? This is kind of one-time setup. And that's the way MVCs need to work. They're object-oriented. They get set up once, and then they just live on their own. They do their own job. They don't talk back to the person who brought them up or to anyone else. Okay? They live on their own. Okay? So you can do anything you want in here to try to do it. One thing to warn you here, though, and half of you will trip over this. When you're doing this preparation of that graph controller's outlets have not been set. Okay? I told you that iOS hooks up those outlets really, really quickly, but this is one case where it doesn't quite hook them up fast enough. Okay? So when you're doing VC property 1 equals whatever, VC call method to set it up, okay, at that time, none of VC's outlets are set, so you can't do anything in the UI. So if you're collecting information for what to do in the UI, you're going to have to store them in some vars or something, and then later, either in the did set of those outlet setters, or I'm going to teach you about view controller lifecycle next week, there's other methods that happen later that you can be assured the outlets are set. Okay? So this is in red. Anytime I put something in red inside, you really want to pay attention. So the outlets are not set in graph controller when you're preparing, in the process of preparing. Okay, you can also prevent a segue from happening. Let's say it's the calculator, and you try to hit graph, and you're in the middle of a binary operation, pending binary operation. Well, you can't graph that. Okay? There's no way to graph a pending binary operation. 3 times? What's the graph of 3 times? It's nothing. So you want to prevent it. So in your assignment 3, you're going to want to use this method in view controller should perform segue. You're going to return false when you're in the middle of a pending operation. Okay? And so that's it for today. There's no Friday section this week. Next Friday section is going to be on performance analysis, because there's going to be an extra credit item in assignment 3 that does that. You'll see that when it goes out. Next week, I'm going to do a demo about all this multiple MVC stuff. I'm going to start talking about the view controller lifecycle, and then a super important topic, protocols and delegation. And then we'll start in doing the more complicated UI things like scroll views and table views. We'll start that next week. Because all you're learning up till now is kind of the basics, Swift and views and multiple MVCs. Once you got that basics in, now you can start doing these more powerful objects. Now, assignment 3 is already on Piazza. You can start it right now. It's got really 2 major points to it. One is a custom UI view that does graphing. Okay? It's really a custom MVC that does graphing. And that thing is completely independent of your calculator. Okay? In fact, I would recommend you create a new app to create that MVC. Okay? Because you don't want to be polluted by your calculator. It's just a generic graphing MVC. Once you got that, you're going to combine it with your calculator, like I'm talking about here, where you're going to click a button and it's going to graph what's in your calculator. Okay? So you can get started on that today because you already know everything you need to know about UI view and doing a custom draw method. So you could start drawing your graph and building that custom graphing view. You could even build the custom MVC because you're building it as a single MVC to start. But you're going to want to wait till Monday to try and hook it up to your calculator because you're going to want to see me do the demo of a split view and all that stuff and see that happening. It'll help you when you start hooking your 2 MVCs, the graphing one and the calculator one, together. And because you need next Monday, this assignment is not going to be due until the next Monday. Okay, so you got a nice 10 or 11 day thing here, but I strongly recommend you use the next few days to go ahead and get started on the view part of it because that's more than half of the assignment and you can make a big headroads into it. The last thing is the last reading assignment also went out today. The due date is pretty much next Wednesday. But that is going to make it so you've read the entire Swift document. So by the end of this assignment, you should feel like you know everything that's in there. Now, of course, I don't expect you to know every single detail about every single thing, but I expect you, if you want to do a nested function, I expect you to be able to know where to go look to find that out. Or you want to do optional chaining and you can't quite remember it, you know where to go look it up. You see what I'm saying? That's a reference document that you want to know what's in there, even if you don't memorize it all. Okay? So that's it. See you next time.
For more, please visit us at stanford.edu.